Let's answer these questions. So in question 1, we have a polynomial in the form of f of x with degree 3. So I'm going to write the general form of a polynomial with the degree 3. So I'm going to write down this as y equals ax cubed plus bx squared plus cx plus d. So this is a polynomial with degree 3, and we have to determine d4 by dx4 of f of x. So let's find out this one. This is once again equivalent to f of x. So first I'm finding the first derivative. So I write d by dx of f of x. This is equal to, I can apply the power rule to differentiate each of these terms. That is a differentiation of ax cubed, where a, b, c, and d are constants. So when you apply the constant multiple rule, this a will remain as it is, and we just have to differentiate only the x cube using the power rule. Which means we have to put the power in front. That is, I put the 3 in front, which is the power of x, and raise x to the power of 3 minus 1. That is, we have to reduce the power 3 by 1. 3 minus 1, this is equivalent to 2. So I write down this as 2. And similarly, we do the derivative of bx squared. That is, b is a constant. Then I put the power of x, which is 2 in front. I put x and then reduce the power 2 by 1. That is, 2 minus 1 is 1. So this is basically 1. I will not have to write it. So it is simply x. And then we have the next term plus cx. So therefore, when you apply the power rule, this becomes c times of 1 x raised to the power of 1 minus 1, which is basically 0. We know that x raised to the power of 0 equal to 1. So 1 times 1 is 1, which means I can simply clear this and we just get the value c. And the next term is a constant d. Derivative of a constant or any constant is 0. So we can ignore that. Let's simplify this, or I write down in cleaner format. This is 3ax squared plus 2bx plus c. So this is the first derivative. Now let's do the second derivative of this one. So I take the derivative on both sides. So this side, on the left side, I will get d2x by dx2 of f of x. And this is equal to, I take the derivative of each terms on the right side. So here I have 3a as the constant. The derivative of x squared is 2x when you apply the power rule. And then we have 2b, derivative of x is 1. So it is 2b times of 1 is 2b. So we can simplify the first term. This is 3a times of 2x is 6a 2x. So I'm going to write down this as 6a 2x. I'm sorry. It's 6ax. Because when you multiply 3a with 2, we get 6a, and then we have 6. So this is the derivative or the second derivative of f of x. We'll do one more derivative, that is the third derivative, d3 by dx3 of f of x, and we apply the power rules wherever it is required. So derivative of 6ax is 6a times of derivative of x is 1. So it's basically 6a. And then derivative of 2b is a constant, which is 0. So we get only the derivative as 6a. Now we will find the fourth derivative. So we write d4 by dx4 of f of x. And clearly we can see that this is 0 because we just have only the term 6a, which itself is a constant. So derivative of a constant is 0. So therefore the fourth derivative of f of x is 0. We now do the question number 2. So in this question, we have to determine the slope of the tangent line for the curve y equals natural logarithm of absolute value of x. Actually, this is natural logarithm of absolute value of x. That's the actual question. So I'm using this same curve equation, and we have to determine the slope at x equal to negative half. So first we find the slope of the tangent line. Notice that the slope of the tangent line is nothing but dy by dx. So we will find dy by dx using this curve equation. So when I take the derivative on both sides, I get dy by dx on the left side, and derivative of natural logarithm of x is 1 over x. And now we have to evaluate this slope. This is basically the slope of the tangent at any point on the curve. But we have to find the slope of the tangent at x equal to negative half. So it's just we have to substitute x equal to negative half into the slope. So let me substitute here. So I replace x by negative half. You know that we can multiply by its reciprocal if you divide by a fraction. So I write down this as negative 2 by 1, which is equal to negative 2. So therefore the slope of the tangent line at x equal to negative half is negative 2. We now do the question number 3. Here we have to find the slope of the normal line for the curve f of x equals tan x or tangent of x. Notice that we can find the slope of the tangent line first. We know that f prime of x, which is the derivative of f of x, this is the slope of the tangent line. And once we know the slope of the tangent line, we simply have to take the negative reciprocal. Negative reciprocal of the slope of the tangent line gives us the slope of normal. So we will utilize this concept to determine the slope of normal line. So let me use the function f of x equals tangent of x. Now let me find the derivative both sides with respect to x. So therefore this side I will be getting f prime of x, and derivative of tangent of x is secant squared x. So first we will find the slope of the tangent line at the point x equal to pi by 3. So we have to substitute x equal to pi by 3 into this equation. And when I do that, I get secant squared of pi by 3. And this is a standard value from the trigonometric tables. This is equivalent to 2 square, so which is equal to 4. So this is basically the slope of tangent line. To find the slope of the normal line, we have to take the negative reciprocal of the slope of the tangent line. So it is equivalent to slope of normal line is negative reciprocal of this slope. So which means we have to do like this, that is negative 1 over slope of tangent line. Now let's substitute the slope of tangent line, which we have just found out. So this is going to be negative 1 over 4. So this is the slope of the normal line. And this means we can mark the answer for this question as negative 1 over 4.